on to the next one is now we're gonna go to perpendicular lines. Perpendicular lines are very simple, are just two lines that intersects. Oops, let me zoom out. Perpendicular lines are just two lines that intersects and form a 90-degree angle, or technically a right angle. So whenever you see a right angle, then they are called perpendicular lines. Right angle is just talking about the angle itself, but here it's saying that whenever two lines intersect, then they form a right angle. Example for this is like the roads, right? You see them crossing at a perpendicular line to each other. Here, to determine that it's perpendicular. What else is other perpendicular? Your book, right? Your shelf. You see a lot of right angles. When two wood are crossing each other, then they form a 90-degree angle, right? What else? Your monitor, they form a 90-degree angle, which means that the base and the height are perpendicular as well. Okay, so just we'll learn more about this later. Here, how do you determine it's perpendicular? I found three ways to do it. It depends on how you want to do it. The first way is they are perpendicular if there's two conditions. They have to be opposite integers and they have to be a reciprocal from each other. Kind of like different from this one, right? Here, all you have to determine is they have the slopes are the same, right? Here, you have to determine that two things here is if they're opposite integers, and two, if they are reciprocal of each other. Okay, and we're gonna go on to this later on. Just basically saying that when a vertical slope and a horizontal slope intersect, then they form a perpendicular line. But we're not gonna go into that yet. So here's an example of how you can determine if they are perpendicular. Here you have a positive plus 2 over 3x plus 5, a positive 2 over 3. Again, I'm just looking at the slopes. Here you have a negative 3 over 2. So you have here, if you're looking at this, you're really looking at the condition. Are they opposite integers? Yes. One's a positive, one's a negative. Are they reciprocal from each other? Reciprocal means if it's 2 over 3, then the reverse form of 2 over 3 is 3 over 2. So 2 over 3's, when they switch the numerator and denominator, then it will turn to 3 over 2. So they are reciprocal of each other, right? So here, both of the conditions apply, which is opposite integers, positive, negative, and reciprocal means they switch the numerator and denominator, which they did here. Then I can tell that just by this information alone, I can determine that they are perpendicular slopes. Okay. Another example here is the third way. This is the third strategy. Is you can multiply the two slopes, and if they equal -1, then you can determine that it is a perpendicular. They are perpendicular. Okay. So here, if it's 2 over 3, 2 over 3 times -3 over 2, 2 times -3 is -6. 3 times 2 is 6. And then -6 divided by 6 is -1. If I get the product of -1, then I know that the two slopes are perpendicular. Okay. I'm going to show that later after our example here. So using that fact alone, using these three, if they are opposite integer and reciprocal, and if you multiply the slope, then they are perpendicular if it equals to -1. Let's try to see if you can do it on the right side. Okay. So I want you to see which pair of slopes are going to be perpendicular from each other. There's three, but there's only going to be two answers. Two of them that are going to be perpendicular. Is it A and B, A and C, or is it B and C? Once again, one thing you can do is you can look at first, are they opposite integers? And number two, are they reciprocal of each other? That's my way. I like to look at that version. But if you're not sure of yourself, then you can always multiply the slopes together and see if they're going to equal to -1. So here we can compare. If we're comparing A and B, it's a possibility. Why is it a possibility? Because one's a positive and one's a negative, right? I know the answer cannot be B and C. Why? Because both of them are negatives. So I know that the third answer should be incorrect, right? B and C shouldn't be an answer because they're both negatives. They have to be opposite integers. So A and B is a possibility, but I have to go to the second condition. Are they a reciprocal of each other? Okay. Reciprocal means that the numerator denominator has swapped, right? Here it's 5/1. And did the numerator denominator swap yet? No. It's still, this is 5/1 and this is still 5/1. So they're not reciprocals from each other. Okay. So what about A and C? All right, one's a positive and one's a negative. So the opposite integer rule kind of applies. So here 5/1's reciprocal is 1/5. Do I have a 1/5 here? Yes. So if I replace the numerator and denominator from each other, 5/1 will change into 1/5. So it did pass through the rule of opposite integers, which is positive and negative, and it did pass that they're both reciprocals from each other. Knowing that as a fact, then I know that these two equations or slopes are perpendicular from each other. Okay, so once again, if you're not sure of yourself, you can always solve it, right? You can do 5 over 1 times -5/1. I'm doing A and B, just double check the students, since majority of students still answer that. 5 times 5 is -25/2. So is that will that equal to -1? No, right? That's so off, which that is not a valid answer. Let's try the other one. Okay, we'll try this one here, which is, we're going to go from A and C, which is 5/1 times -1/5 equals 5 times -1. Here is -5, and 1 times 5 is 5. -5 divided by 5, that will equal to -1. Since I know it equals -1, then I know that they are perpendicular. Okay. This is for the students that are not sure of yourself, right? If you don't really believe the opposite integers are reciprocal of each other rule, then you can just multiply the two slopes, and then you can find if it's perpendicular or not. Okay. So that's just an example of how to do it. And of course, we're going to graph that just so we have a visual of what we're doing. We're not just doing work, we're visualizing, right? So it's y equals 5x plus -2. Hold on. Okay, it's showing sweet. And the next one here. So here we're trying to determine if it's a sort of a right angle, right? There's no way to determine it because we don't have, if you're here in my class and we have like I have a protractor I can show right in front of you, but I do not have that tool, so it's kind of difficult. So we're gonna just use estimation, okay? Y equals -1/5 x over 5x plus 4. So here we're gonna go. I know here it doesn't look like it, but if you use a protractor, which I can't really use right now, me and my student did this um, in my face-to-face class, and we showed it, and here it showed that they are perpendicular. Okay, we used the protractor to measure it. If you want to use a protractor, if you have a protractor at home, then you can do that as well. Okay, or if you have like how do you explain? You have something that's a perpendicular and you can match it, that's a perpendicular, that is another way. Okay. If only I can tilt it, but I can't because we're limited in this. Can I rotate it? I wonder. No, I can't. I wish I could. Rotate it. Come on. Can't rotate it. I apologize for that. But yeah, this is an example of how perpendicular lines look like. Maybe you look something more familiar with this kind of example. Another example for parallel lines are when a vertical line, horizontal line, like I was mentioning earlier, and a vertical line intersects, which is once again y equals anything, any value of the y-intercept will be on a horizontal line, and a vertical line is going to be x equals any value that's in the x-intercept. But right now we're going to just choose 6. I don't like the color. I don't know how to switch it because I'm kind of new to this. So there you go. So when you see here, this is where they meet, right? So you have a horizontal line, which is x, y equals 4, right? Horizontal line that's y equals 4, and a vertical line that is x equals 6. Okay? And when they cross, do you see a perpendicular line? Yes, there's a perpendicular line.